Welcome everyone. I can see that people are still joining Zoom, so please wait a few seconds. Can you hear me and see me well? It would be great if somebody answered on chat or somewhere else. Okay, I can see some answers, but I don't have my chat open yet. Okay, you can hear me and see me. Great. Now we have some users on YouTube as well. That's great. Welcome. You can join the Zoom. I share my screen. Like you can see exactly the same thing as that on YouTube, but you can ask questions live. That would be better, I think. When you join Zoom, please mute your microphones as well. Okay, everything seems fine, so I think we can start. I hope that you can hear me both on Zoom and on YouTube. Welcome everyone, my name is Paweł Żak. I'm the president of the Data Science Club. This is the second meeting from the Data Science from Scratch series. If you were absent at the first one, you can either skip it or watch it on YouTube, although at some point I forgot to turn on my microphone on YouTube, so I apologize. Oh, it's private on YouTube. Okay, so maybe I set it to private because it was muted for some time. It doesn't matter as long as you know what data science is. You should be good to go. And if not, this class, not class. I wouldn't like to call it like that. This meeting won't be about data science. It will be about something that you need to know before you can learn data science. So in our case, it will be Python. Yeah, I think we can begin. So at the end of last week's meeting, I told you that I forgot, not forgot, but we didn't have enough time for me to show you some projects to maybe inspire you and make you come to my classes more often. Yeah. So we'll begin with that. Let me just change my. Yeah, you should be able to. Oh, you can't see my camera right now. Let me just fix it. Can you see everything on Zoom? Because it seems that something is not working. Okay, thank you. I'll try to add it again. Oh, it should work now. Oh, you can see me. Great. And it should be visible at YouTube as well, so everything's fine. Great, okay, so projects, right? I'll use Streamlit. It is a Python library that allows you to host your apps, your GTP notebooks onto websites in an easy manner. So maybe I'll show you firstly Streamlit hello. Let me just open a new browser. Okay. So yeah, there's not much for me to say about these projects. This is just a showcase of what can Streamlit do. We can basically put plots and text with Markdown onto it. This is the code that was used to generate this whole page. As you can see, it's small, so and easy to understand, hopefully. Maybe not at the moment, but definitely soon. Oh, that's... So can you... So what can you see then? Oh, I'm sorry then. I think that on YouTube everything works fine, but let me just stop sharing my screen on Zoom and share it again because it froze, it appears. So, oh no, that's the issue. You should be able to see everything, not yet. Let me try it again. I can't start my virtual camera on OBS, so maybe I just share my screen instead. You won't be able to see me unfortunately, but at least you'll see what I do, and I'll try to fix it in a moment. So now you should see my screen on Zoom. Is that right? Okay, great. So what I did, I just started a let's say Streamlit Hello World program, and as you can see in browser we have different kinds of projects that Streamlit is showcasing their software with. The code that was used to generate those projects is short and easy to understand. After a short explanation, we'll get to it in the future classes, but as you can see, it's a very powerful tool and we can do many different things with it. Yeah, so maybe another project that I'd like to show you is also in Streamlit, but the one I found on GitHub and found interesting, it would be this one. No, it's taking some. Oh, what? Okay. Stream. I can't type. Streamlit run st. Yeah. So what this program does, it checks whether the person on the picture wears a mask or doesn't. So earlier today I took 2 photos of myself, one with a mask and one without, and we will see if this works. I know that it works, but I'd like to showcase it to you. This is a photo without mask, obviously, and as you can see, the algorithm that stands behind this program is 100% confident that I do not wear a mask. What a data scientist would do is they would program this algorithm that checks it. And at the photo where I have my mask on, you can see that the algorithm is 100% sure that I do have my mask on. We can imagine what could be applications for such software. So maybe let's move to another project. Maybe I'll show you my personal ones. Excuse me for a second. Okay. Yeah, so these are not like strictly data science related projects, but they are, I don't know, maybe inspiring for you, I hope, at some point. These are not complicated things, so we'll be able to do such things on our classes if you'd like. Classes, I said it again, I wouldn't like to call these classes because I would like you to interact in a normal manner and not like on lectures at universities where you have to be more strict, let's say. No, not this one. Let's show the other one first. It will take a second to run because I used TensorFlow in this one to make the algorithm. So maybe I'll introduce it shortly. Yeah, so this is a Pint program where you can write digits and the machine learning algorithm predicts what kind of digit is it, and not what kind of digit it is, but what digit it is. This at the moment we're using k-near. This is the neighbors algorithm. As you can see, it doesn't work so perfectly, but if we change it to neural network, it should predict correctly that it is number 3. I implemented only 2 algorithms to it before I got bored with this project, but you can only imagine how many ways there are to solve such problem. Another one that I'd like to show you is a game I made. You probably know the game Don't Touch the Spikes. It's one of my favorites from the time where I had more time to play games on my phone. Yeah, let's run it, and the game looks like that. You just jump with a bird, avoiding these spikes. If you hit the spike, you die. And the thing that I did with it is that I trained a neural network to learn to play this game itself. So here is a training process visualized. As you can see, this algorithm works in different generations, and after many generations of these birds, it learns to play the game well. I did not implement the way to get out of this screen, so I'll just rerun the program, and I'll show you the end product. This is an AI playing this game. These are sort of things that we could do here at Data Science Club. Yeah, that's it. Can I speed it up? Yeah, I can speed it up, and the bird goes a long way. That doesn't matter. What we'll do now is I'll introduce you to Python, because this is the proper programming language we'll use here to do data science. For those of you who already know Python, I don't think that you'll learn that much. Maybe some small details you missed before. But for those of you who don't know Python, yeah, I hope that you'll learn a lot. Please ask questions if you have any at any point. I lost my chat for... Oh, okay. Yeah, 99% confidence interval, right. I can see the chat now, so everything should be okay. You can ask questions, or you can just turn on your microphone and ask questions this way. What I'd like to begin with is... so Python is an interpret object-oriented high-level programming language with dynamic semantics. We shouldn't focus on this definition too much. For those of you who can understand it, you probably programmed before, and that's great, because I kind of expect you to know at least one programming language beforehand. I won't teach you programming here. What dynamic semantics means is that we can define a variable twice. For example, firstly, we can assign an integer to a variable called a, and then we can assign a string to it, and that's not a problem for the Python programming language. Python is mostly based on the libraries that users wrote to it, because Python itself is not the most efficient language you can use, but there are many libraries that work on C or C++ on the backend. So these are the ones that allow us to use this language in a more efficient manner. So the first thing that I wrote down here to tell you is pip. What pip is? It is a package installer for Python. So you can publish a library, and other people can download it. And obviously you can download many open source libraries for Python. Most of data science, if not entirely, you could say, is based on these external libraries wrote by someone. Another thing that I'd like to talk about is Conda. You may have noticed before that before I started typing anything in the terminal, I wrote Conda activate Streamlit. What Conda is, it is an open source package manager and environment manager for many different languages, not only Python, but it was created for Python, I believe. So Conda quickly installs, runs, and updates packages and their dependencies. Why we use it is the reason why we use it is that it allows us to load and switch between environments on our local machine. So we can run a few different versions of Python on our machine without any big problems. Why would we need to do something like that? You can ask. We need such tool because there are libraries that are available only for older versions of Python. So if you'd like to use one, you then have to install a different version of Python to run this library. Anaconda is like a bigger software around Conda that installs many different things alongside. It was created mostly for data science, I believe. So by installing Anaconda, you'll have most of the libraries necessary for data science installed already, as well as a Python will be installed for you as well. So if you don't have Python on your computers yet, I encourage you to install it with Anaconda and to watch a guide on it on YouTube or somewhere else, because it is very probable that you won't have your path set correctly and it won't work. Doesn't matter, just do it with some kind of tutorial to ensure that everything's work correctly. So we can write Python code in many different ways. We can write it in a terminal by simply typing Python. Now we have like a Python shell where you can type commands and Python will process it. So for example, we can do maths here. Is Linux preferred OS for working with Python? No, it's not. I'm on Windows actually, but I run Python through WSL, which is a software that allows you to run Linux in an efficient way on Windows. But no, you can definitely do everything that one does on Linux on Windows. So we can see that if we type 4 plus 5, it returns 9. We can do all sorts of mathematical operations in the Python shell. The same ones. We can basically write any code you would write in a normal file with Py extension. I don't use Python shell because there is a library that allows us to run Python shell in a more advanced way, let's say. It is IPython, and maybe you can install it by typing pip install python ipython, and if you use conda, you can also use conda install ipython. So yeah, IPython basically is the same thing as shell, but it has many more features than normal shell does. For example, one feature would be the ability to to measure how long time does a certain operation take. To do so, we start the command with this sign. It allows us to use these magic IPython functions. This is the name of it, magic functions or whatever. Yeah, magic IPython or something like that. I'm not sure, but if you type time, for example, and then some operation like 5 plus 4, it tells us how long did it take to compute it. You can also put a function here, but we'll talk about functions later, so I won't show it. Another magic Python command that we would use often is, for example, whos. It displays all the local functions and variables that we have in our IPython environment. So if, for example, I assign 5 to A, this is how you define a variable in Python without any types. And I now type whos, you can see that we have A in our environment. I can now redefine A to be a string by writing a string here, and as you can see, A is this string, and if we do whos, now it is a string. You can define strings with both single quotes and double quotes. Sorry. Another interesting thing that you can do with with Python strings is f strings. This this is a thing that was added to Python in Python 3, and it allows us to add variables into our strings. So we defined a variable A and assigned 5 to it, and now we can print. Print is like cout in C++ or C, not in C, or printf in C. So yeah, it's basically the way to display something onto our console. And now we define a f string. F string is just a string but with an f at the beginning, and we can type something in here. So let's say that a is equal to, and now with these curly braces we can input a variable into our string. So as you can see, through doing that, the value that it was assigned to A gets printed out. Logical operators are in Python are like in any other common language. So, but you don't define it with these signs like in C++, for example. You basically type what you have in your mind. So and, for example, or yeah. We'll use it probably more later. Another way to write Python is through basically typing it into a file. The file has to have an extension .py, and we can define variables again here, and maybe I'll do the same what we did in the Python shell, but through a script like this one. We can, in IPython you can also use your normal terminal commands by typing an exclamation mark at the beginning, and you can also access the value that got outputted from the previous input. So what I mean by that is that if we write 5 plus 4, it is 9, and we can use this floor sign to access the value 9 that we got outputted in the previous operation. Yeah, so we can now, for example, do this plus 5, and it is 14. That's all about IPython that you need to know for the moment. Let's run this script just to show you that it works the same. I don't have it here, so I'll create a new one. Oops. I have this one here in different location, and I just figured it will be easier to do this way. So let's close this one, and we'll have this new file here. Why can't I put it here? Doesn't matter. So yeah, we have our script here. It can be written in any text editor. I use Visual Studio Code. I find it the best one for Python. Can you hear me? Because it looks like my computer froze there for a second. So let's wait 1 second so it unfreezes. There is a question. Pit install IPython, then IPython in command, and it does work, and it doesn't work. Any ideas? Yes, so you may need to include a path into Windows variables. So the way you do it is you search like the Windows and then S to search and type environment NV just and such window should appear. System properties, and now you can go into environment variables, and you have to edit the path variable. So you edit it, and in case of IPython, you probably have to add this path there. It is a place where Python stores all scripts like that, I believe. Or yeah, so basically in the place where you have Python, there should be a folder called scripts, and if you include it into the path variable, you should be able to access it through command line this way. It looks like VS Code stopped working, so I'll just close it and reopen it. Maybe not. Sorry about that. Everything should work now. Yes, so we have our script here, and you can run Python scripts through terminal by just typing Python and the name of the file that you'd like to run, in this case datascienceclub.py. If we run it, the a is equal to 5 gets printed out as in our script. Python executes the script from top to bottom. Yeah, that's why it works. One second, I'll reopen the, let's call it presentation. Yeah, so at this point it is also good to mention that this presentation was made with Jupyter. That's another way we can write our Python scripts, not scripts, but our Python programs. And this is, let's say, default way that data scientists use, because it allows us to run a short part of our code and without running all of it. And it also allows us to use Markdown to create such such text, as you can see here, and that we can also add photos and do lists, do tables, all sorts of different things. You can search in Google Markdown cheat sheet, for example, to see all the different things you can do through Markdown. Oh, thank you, it works now. That's great, I'm glad. Yeah, so maybe I'll create a new Jupyter notebook. The default way to do it is through command line. You type Jupyter notebook, and now a bunch of text is being printed, and oops, an error, that's unexpected. So shut down, yes. Maybe I'll run it from Windows. And I need to open another window. Yeah, and then we just copy this link, right? The first link that appears there, and paste it into our browser, and we have our Jupyter notebook. It probably looks different for you because I have some theme applied to it. but this is how this is like the interface through which we access the different Jupyter notebooks, and we can create new one. And there you have it, our Jupyter notebook where we can execute code. Code in cells. So for example, I can do a equal, oh, we can't see anything probably. A equals 5 here, and print a in here, and add another cell where I can write totally different code, like print whatever, and we can execute this cell and this cell independently, like if we had many scripts in the same file. If you have IPython installed, you can do the same thing through IPython. Thanks to IPython. Let me reopen the file that we worked in previously. You can define cells in a regular Python file if you have IPython installed through writing hash and 2% signs, I believe. Yeah, and now we can run cell, and to create another cell we can do it again, but that's not something that we commonly use, so you can basically forget about it. We'll use Jupyter notebooks, and I will use Jupyter notebook in VS Code because it has such option. That's why I also that's the reason why I recommend Jupyter notebook for writing your scripts. I'm not sure if I chose the correct environment. And in Jupyter cells you can execute code just like in IPython. Okay, maybe let's choose this one. Yeah, so it doesn't matter for the moment. We have our Jupyter notebook here. Another thing that we'll talk about are data types. There are some unique data types that come with Python. So, for example, you probably know integers, floats, and maybe not complex numbers. There is a complex numbers are inside Python in default, but we probably won't use them, so I won't explain it. But there are some unique data types like dictionaries, sets, tuples, lists. So let's go through them. Let's add another cell. I did it with this plus sign, and we can delete cells here. So a tuple can be defined in two ways and assigned to a variable. So for example, let's define A. The first way is to write tuple and then some values inside it. What tuple does, it doesn't allow us to change the values that were inputted into it in the first place. So if we print A, sorry, okay. We have to put a list into a tuple or another tuple or something like that. So yeah, now we changed, we defined list with square brackets. I wanted to talk about tuples first, but Yeah, we'll use just a list. Into a list you can input many different variables, different data types. We can have integers, strings, booleans, all in the same list, or a tuple. So as you can see, A is a tuple, and we can access each value of A with these brackets, square brackets. So its indexing in Python starts with 0, so the first value is 4 and the third value is 6, for example. But if we were to change one of these values, we can't do so. So let's change A at 0 into 7, for example, and as you can see, there we have a type error. Type tuple object does not support item assignment. Tuple is a class in Python, so it has its methods. One of such methods is count. Maybe let's add another force into here, and now we can do a.count 4, and as you can see, it returned 3 because we have 3 fours inside our tuple. Yes, another method that I'd like to show you is that we can find a value. We can find an index of the value. So is it blinking for you as well? It is, probably, because I'm sharing the screen. I don't know why it does that. That's probably annoying. I'm sorry. So if we that annoys me. We can find the index of 6, and as you can see, it returns 4 because it is at the 4th place. Why is that doing this? It's blinking all the time. Yeah, another data type in Python, lists. Lists can be another way to define tuples is just by using these normal braces. So we can define a tuple again, and it is a list because and now we don't have to put a list into it. We just put the values that we would like the tuple to have inside. We can define lists also in 2 ways. Each of these more complex, let's say, data types that I talk about can be defined in 2 ways, either by saying list and now inputting something else into here, for example a tuple. We can change this tuple into a list, tuple 456 into a list, and it returns a list. And the other way is to just use square brackets, so we can define a list this way. Lists also come with many different methods. I'll go through few of them, but I encourage you to look into the documentation yourself. We can append a value to a list, so we append 8 to this list, and now let's see what's inside A again, and we have 8 inside. We can also insert a value. I'm not sure how this method works, so yeah, it takes 2 arguments. So it's probably for inputting a value into a certain place in the list. So yeah, we inputted at index 2, we inputted value 10. As you can see, we have it there. Each time I execute the Jupyter cell, it gets executed from top to bottom, so it refreshes every time. It says that A is equal to that, and then we insert. That's why we don't have an 8 in this list as we had before, because we redefined A by rerunning the cell. We run this out by clicking run or control enter. That's what I do. Another method we can, and yeah, another method. Let's remove a. I'm not sure if it takes index. No, it removes a value. So we can remove 4, or we can remove 5. And if we have 2 5s inside, only one gets deleted. The first one there. What extension are you using for Python? I'm using the Microsoft one, Python, this one. It also comes with the option of running Jupyter notebooks inside VS Code. So yeah, I recommend it a lot. What else? So we can remove a value from a list by using the method remove and then removing the value that we'd like to remove. And the other way to remove a value is through index. So we can do delete a at index 0. And if we print a again, we won't have a 4 at the beginning. We only have 5, 6, and another 5 because we deleted the value that comes at index 0. This can be used in any other different data types, such as dictionaries, that we'll go into in a second, because I'd like to show you these different methods as well. We can pop a value, so a.pop returns a value from the end of the list. We can do it a few times. So if we do again a.pop and now so what's inside a, we can see that we popped a value twice, so we only have 4 and 5 inside it. We can sort our lists by calling the sort method. It got sorted, as you can see. 5 went before 6. Now dictionaries. Dictionaries allows us to assign one value to another one in an easy manner. So we can, for example, say that a is equal to 1, and this is the first value of our tuple. Let's call b. Let's say that b is equal to 2 and c. What? Oh, I have to change my. Okay. And c. And we assign 3 to it. In such form, the data usually comes to us, maybe not through CSVs, that doesn't matter. Forgot what I said. So yeah, we have a tuple and we can access each value. For example, we can, or maybe I'll call it a different way, let's call it temp. And we can access temp A and it returns B. We cannot access temp at C and it returns 3. We can call a.keys to show all the keys. The first value in a single value of tuple is called key. So our key to value 1 is A. And the value 1 is called an item. We can call temp.items to show each value. No, sorry, I said something wrong. Item is both value and its key. So we can call temp.values. I'm sorry. We can type temp.values to show only values. We can do a.keys to show only keys, and we can show all the items that are in our dictionary by calling items. We can pop a value from a dictionary. We have to give it a key to pop it, and as you can see, it returned 1. So if we see what's inside our dictionary, we popped the value a. We can also pop item. Sorry. Oh, what does pop item do? Oh, so pop item just pops the last item of the dictionary. We can also use get. Get the value. I'm not sure why we would use such method, but I'm sure there is a use case for it. Yeah, so these are dictionaries. If you have any questions, please interrupt me at any point, because I'm not sure if I'm explaining it in a good way, in an understandable manner. Okay, we don't have any questions, so I hope that you understand everything well. Another data type that is unique for Python is set. Set is exactly what it said it is. What it says it is a mathematical set. So if we were to define a set that contains for example, three threes inside it, if you should expect that it will return only 1, because these are mathematical sets. And oh, sorry, we have to put in a list into a set function to convert a list into a set. Set doesn't have its own braces to represent it, because Python developers went out of braces, and you use sets the list, so so you can define a set only by calling the set function on some other data type. So as you can see, it only returns 1 3, because mathematical sets can't have duplicate values. We can compare two different sets, like in mathematics. We defined now 2 sets, A and B, and we can, for example, call A dot difference B, and it returns 3, because this is the difference between those 2 sets. We can also do union and probably many other mathematical operations that you know from your maths class. Yes, let's move on. These are the maybe less familiar data types for those of you who never programmed in Python before. Yeah. Now let's go into syntax. So we already saw a bunch of saw how to define different things, but we didn't talk about functions yet. So to define a function, we use a keyword def. Then we type a name of this function, braces, and then a column. Inside these braces, we can define different variables that we wish this function to take, for example, A and B. We can also give default values to them, so we can say just B is equal to 4. And inside our function, we can write code, obviously. And to return it, we just type return it. For those of you who come from languages like C, for example, this may seem unfamiliar because this may seem weird, because what you would do in C is you would use these curly braces to define to the interpreter where our function is. In Python, we use 4 spaces or 1 tab to tell Python that the code that we are writing is inside this function. So indents in Python are the same thing as these curly braces in C or Java or other language you may know. So yeah, to write code inside this function, we have to type 4 spaces, and then we can then Python knows that this code is inside this function. So we can print, for example, A plus B, very simple function, and we call this function just through typing its name and then passing variables to it or values. So for example, we can call it with 7 and 8, and it returns 15 as expected. We can also not define the other value at all because we have default value set to be. So in this case, it will return 11. There is, if we need a function to while declaring b equal to 4, we have a question on YouTube. For no particular reason in this example, you can I just made up the value 4. You can okay, I get it probably. So this is a default value that B would take if you don't specify, if you specify only one argument in the when you call a name function. So as you can see here, if I call name with 1 without the B argument, it's defaultly took value 4 so it returns 5. There is something that's called lambda function. This is a syntax that we would use to define short functions. For example, if we would like to represent a mathematical function x squared, let's say, we would, if we were to define a normal function to it, to do such thing, we would probably write code like that and return a times a to square the value. Maybe it's not the best example because in Python we can use use this double star sign to square a number or to raise a number into a power. There is another question on YouTube. I meant while declaring this in the function local variable, I guess. No, it's in many different languages. In C or C++, I'm sure that it has this function as well. So we do it to define a value that this variable will take if we don't specify it while calling the function. We wouldn't like to define this in such a way. and now assign b to 4, because now we override the thing that the user typed into the function. So by giving it a default value, we ensure that we give the ability not to define both values while calling the function. Yeah, that's it. So, lambda functions. Let's say that we would like a function that multiplies our value by 3. And let's call it triple. If we now call triple 3, we get 9. We can. This is like overly complex way to. Just to def AAA. You don't want to do it because you want this function to take 2 values, not only 1. The function that you defined on the chat takes only 1 value, and I wanted this function to take 2 values, but I also wanted to give a user an ability to only define 1 value, and the other one is default. You can see it. So, for example, in a large program, you may have a function that takes many values, and they don't need to be all defined by the user. Some of them are defined by default. For those of you on Zoom, I'm answering the question from YouTube. If you have any questions, please ask. So we have this function that triples a value, and in Python we can do it in a nicer manner. So we would just assign let's define a value, let's call it tr, and now define our lambda function. We use the keyword lambda, the name of values that we want our function to take, in this case only a, but we could specify b, c, d, as many as we want. Now we type a column and the operation that needs to be returned. So in this case, a times 3. And this does exactly the same as our triple function. Maybe I'll print this one as well. As you can see, both ways returned value 9. This is very useful when we want to input a function into another function. So, for example, that's a great moment to talk about map. This is a function that comes default in Python, and let's define a list 1, 2, 3, 4, 5. And what map does, it applies a function onto a list or some other data type. So as the first argument, it takes a list, let's say, or other data type, and here function. I'm not actually sure if it works with all the data types we spoke about before. So the example will be on A. You can check it yourself as a homework, let's say. So we can input map our A list into the map function, and as the second argument we can okay, so it's like a pointer to a function, right? I'm not sure what this question refers to. Do you mean the lambda? No, lambda is not a pointer to a function. Lambda is a definition of a function of itself. So yeah, lambda is more like an object. True. It's not an object. It is a function. Lambda is a function. There are two ways to define functions in Python. One by calling the def thingy, and the other method is our lambda functions. And here we can define a function. So yeah, just two different styles. Yeah, right. But the lambda functions come very handy in a lot of times. It simplifies the code and makes it more readable very often, and allows us to define a function in one line instead of three, for example. We can use our lambda functions as an argument to the map. But before we do that, I'll just show you what map does. If we were to call sum, this is another function that comes with Python. It sums all the values in our list or tuple. So sum of a is 15. Yeah, 10, 15. It's correct. So we can do map a and then sum without braces, because we want to pass a function as a variable, not call this function. So we call map a sum. Okay, map returns an object, so we have to call it. We have to assign it into another function. I should probably talk about generators before I talk about map. Yeah, let's quickly move to generators, and then I'll go back to map and lambda functions. So generators are this unique thing in Python. That what it is basically something in Python that generates a sequence of values. It is let's call it a function that can pause its execution and resume at any time later. The way we defined such generators is with a yield statement instead of return. I'll show you here. This is our file from before. We can define a generator ABC, whatever, that won't take a value. And now we can do such thing. Okay, let's do print first value. Second, first, and third value. Let's define x at the beginning, and now let's yield x. Now let's increment x by 1 and call again yield x. And let's increment it again and again yield it. What this does, it allows us to call this function, and this function remembers where it stopped. So let me move into IPython. If you type IPython and -a before it, and then a file, all the oh, not Python, IPython dash a and then name of the file. All the functions and variables that are in this file get transferred into our IPython. So if I type whos now, we have our ABC function from here because I code IPython in this way. So ABC is our generator, and we can assign it into a variable, maybe another one. Yeah, temp, and it is ABC. We call it here. We call temp now, and as you can see, it is a generator object because we used yield inside it. And the way it works is that we can use another Python specific function, which is next, and give this generator as a value to it, and it will execute only the code before the first yield statement. So as you can see, we called next, and it returned first value and then 0, as we wanted to do. If we call next temp again, it starts itself from this point and now returns the second part of the code. And if we called next the third time, it returns the third value. We can use it in a loop. It is a good way to introduce loops as well. The way you define loops in Python is by calling for. Then we put in our placeholder value, let's call it I, in, and now we can pass many different things into this for loop. For example, a list. So for simplicity, we'll do such thing. So what this loop does, and after loop we don't use these curly braces, of course. What we do is we type another 4 spaces or a tab to say to Python that we would like the next code to be executed inside this loop. So here we can, for example, print I, and maybe I'll just run it here. Oh, it's WSL. Okay, so let's quit the IPython. And let's call python dsc.py. What happened there? Oh, we don't call this function. I defined this loop inside the function and I didn't call it, so let's call this function abc. And now if I do python dst.py, we can see that it printed 1, 2, 3, 4, 5, 6, the values from inside the list that we defined here. So going back into generators, instead of printing, we'd like to yield this value I. And yeah, let's save it here and now call IPython with this function defined again, whose it is there. We can assign it to a value, and it is a generator again, and we call again next temp. And so I'll give you a second to think about what's going to happen if we call this next. a second is enough, it would return only the first value from the list and then stop the function, because that's how yield works. We saw it in the previous example. So I call next, 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 until we run out of values and we have stop iteration error. So this is a way we can use yield. And why would we want to use yield? Imagine a situation that you have a file where you have stored some information about a client, for example, and you want to take only 2 clients at once into your program. What would you do is you would yield 2 values from this file and do some operations on these two person, and only then yield another 2 people. I implemented such thing while I was showing yield to my friend, so we can run it. Exactly the thing that I was talking about a second before. Yeah, so we have our CSV file. You should get familiar with CSV files. These are just comma separated values, and the data that we will analyze as data scientists and build our models on it commonly comes in CSV files. So we have name, age, sex, weight, and nationality, and all the different values that come under these attributes. In the yield program, what we do is we open the file, we read the first row, and we yield only this row. Oh, I think this program may be a bit too complicated for such beginnings with Python, but let's only show what it does. Oh, it is. Comments in Python, we input comments into our code by writing a hash and then our comment, or another way, if we want a larger block of comment, is to type 3 3 of those things, or our comment in here, or the small ones also work. Auto completion is not making my life easy at the moment. Yeah, so these are the 2 ways to define to write comments in Python. So what this program does is that it allows us to do some operations only on 2 values. Maybe sorry about that, but I was not prepared to show this code beforehand. Let's run this cell. And run the other one. And okay, what this says is do something here. I don't know if it's a waste of time to show it or not, but as you can see, we only returned 2 values from this previous file. We did some operations on it, and we returned another 2 values. We did some operations on it, and another 2 values, and we did some operations on it. Let's leave it as that. Generators. So these are generators, and we can use generators in for loops, for example. A generator that comes in default in Python is range generator. It allows us to create values between 2 ranges. So we can specify a range from 0 to 10, and now print it. Print I. It is a generator, so it is not a generator, but it works in a similar way. So as you can see, our range function returned value from 0 to 10, and 10 is not included. We can specify a third argument into range function, 2 for example. It means that every second value will get printed out. 0, 2, 4, 6, 8. Yes, so another function that we can use in our for loops is enumerate. And enumerate takes a list of values. It's a great place to show you the power of Python. We can define lists with loops. So inside, and it is the best way to do it, because it's way faster than creating a list in a normal manner, as you would do it in C or C++. So if we want a list that contains values from 0 to 10, we can do I for I in range 10. And now if I print A, let's delete it for a second. As you can see, we have values of A. Another way to take out values from range is by using the star argument. It unpacks this range object. So it returns the same thing, and this is the most Pythonic way to do it. Okay. Let's now get back to our map function. Map can be unpacked in the same way as range was. So to get out values from map, we have to unpack it. We could say I for I in map, a sum, just as a reminder. Map takes a list or as the first argument, and a function that you would like to apply to each value of this list as another argument. Yes, so to each value of this list. So we wouldn't like to specify sum in this case, because we can't sum one value. So we can define a lambda function here, for example. We can call lambda x, and x, let's return the squared value of each of this list. Just tell me if you understand what I'm doing or not. Function object is not iterable. Why is that? Oh, other way around in map. You're right. As the first argument, it takes a function, and as the other one, a list. Thank you, Wojtek. And if we print B here, we can see that each value of this list got changed by the function we specified in the map. we don't have to do I for I in map. We can just use this star and it will do exactly the same thing. Another function that can be unpacked is zip. It is another useful function which just takes two lists and makes one list out of it. We can specify another list. Let's do it in a better manner this time. So we specify another list B, range, let's do 5. Or maybe not, from 5 to 0 and decrement it by 1. So what will this do is, maybe I'll just show it what it does. It creates a reversed list A, because we start at value 5, we finish at value 0, and we decrement it by 1 every time. Yes, so if we have those two lists, we can define a list C, which would be a zip of these two lists. You'll see what zip does in a second. We can zip A and B and unpack it into C. So maybe I'll do it for I in zip to make it more clear, I hope. And if we print Z now, for I in zip, why is this? Oh, because we specify what we want to do it with it first. Yes, we get tuples of zipped, these two lists zipped. So list B was, list A was 1, 2, 3, 4, 5, list B was 5, 4, 3, 2, 1. So we got this value comes from list A, and this value comes from list B. Value from A, value from B, value from A, value from B. And if we would like these values not to be tuples but lists, we would modify our I value here. We can say that we would like this I value to be a list. Now if we call it, we can see that we have list here, and we can modify this value in any way. So maybe I'll go back to the definition of a list in this Pythonic way. We do it like that, as I hope you remember, and in this first argument we can do whatever we want with this range, with this unpacked range. So what happens here is we take the first value from this range generator. That's why it's not a generator, but knowing generators helps to think about these objects. So we take our first value, assign it to our first value from range, and assign it to I, and then we raise it to the second power. And then we can take second value from range 10, which is 1, and we do it each time. So we get a list of 10 values, 0, 1, 4, 9, squared I, right? It was someone asking a question? Yes? It doesn't work then. For such cases, there is a Python built-in library that allows you to modify it, to do it. So if I yeah, let's show this example. We zip A and B. It returns, oh, it did return something. That's surprising for me. I need 1, 2, 3, 4, 5. Oh, okay, so then it only it stops at the point where the shorter list ends. So B is yeah, so these are our two lists, and as you can see, only the first 5 values from the B list got zipped with A list. Regular function that we use to print comes with different parameters as well. We can specify a separator between two values in that we pass to the print statement. We can set the separator to be the end line sign. So as you can see, previously this list got printed out next to each other, and we specify a parameter sep, and we could give it an end line there. They get printed into another line. We can also set it to a string, and it got separated by this string. Oh, let me see if I missed something. Is instance function allows us to check if something is an instance of a type. So A was a list, and is instance A int, for example, will return false, because A is not an integer, it is a list. So if we give it a list, it returns true. Same thing can be accomplished by doing such. Think A is list, and it returns false. I'm not sure why. Okay, that's something I'll have to check. And maybe I'll update you on that on the next meeting. On the next meeting, we'll hopefully do some more interesting things, but we have to get through the beginnings to get to the interesting part of data science. There are multiple libraries that come as default with Python. For example, OS library. It is a module that provides us with a portable way to use operating system functionality. We can access different paths on our computer through OS, and many different things. You can check its documentation online. Another library is time. Maybe I'll show you how to import a library. To import a library, we simply call import time, for example. And now we can call time, and a function that is inside a time library is, for example, sleep. Time sleep 4. If we run this cell, it takes 4 seconds to execute it, because we called time.sleep. Maybe I'll print something here. Yes, it waited 4 seconds before it printed this gibberish. We can import time with a specific name. Import time as t, for example, and we can call t. Then instead of calling the full name of this library, we can use only the t thing. And we can import a specific function from the library or a class. To do such thing, we would type from time import sleep, for example, and now we don't have to specify anything before it. It just is a function that we have here. Okay, we have about 15 more minutes, but maybe I'll go through these different libraries. So datetime simply allows us to work with dates inside Python. iter_tools is just a library that gives extensive abilities to our iterations. For example, we can use a function that is from the iter_tool library that would repeat a value 10 times instead of a range inside of a function. Instead of range 10, we would call this iter_tools dot cycle, I think it's called. No, it's called repeat. But we firstly have to import repeat, and we repeat value 10 5 times. And let's assign value a to a list and unpack this thing. Not repeat, but iter_tools. And a gave us 10 times. You can check what this library has by yourself from the documentation. Math allows us to do different math operations. Random allows us to generate random variables in different manners. Re is for this specific what was it called? It is regular expressions. This is a way we can manipulate a string to extract certain information from it. It is you can read about regular expressions by yourself. Re is a library that allows us to do it in Python. Collections is a module that provides us with different data types, I believe. Threading allows us to run our Python scripts on different threads of our processor, and multiprocessing allows us to run. We would like to do threading because then the code gets executed faster. We can do operations faster. And multiprocessing allows us to run multiple Python processes at once, again to improve performance. And there are many external libraries that we'll go into in the future, such as NumPy, Pandas, and Matplotlib. The Matplotlib, these are free libraries that we'll learn about very soon. These libraries allow us to NumPy library is a general library that implements all the Python list operations and many different things in a faster manner, because it uses tensors to perform its calculations. Pandas is a library that allows us to read our data frames that we'll analyze and change it in a way that is easier, that we would like it to be. And Matplotlib allows us to visualize data. Yeah, I hope that you didn't get too bored by all this talking, but as I said on the beginning, this is like the prerequisite of data science to know Python, and I thought that doing a short course on basics of Python is a good idea. Obviously, you won't. Oh, there was a question. Oh no, there wasn't. Okay. So yeah, if you have any questions, please ask. You surely won't learn all these things just from this 2-hour meeting, but I hope that it gives you a broad understanding of Python and all the different things that you can do with it. So yeah. Again, thank you for your time, and yeah, I hope to see you soon. Next week we will have a special guest to do a lecture, so we won't have this regular data science from scratch series. So we'll probably meet for this series again in 2 weeks. If you have any questions, I will be here till for 3 more minutes. So please ask anything.